Hi guys, welcome back to the channel. So today we are going to be solving today's lead code question, which is sum of left leaves. So we are given a binary tree, which will represent the binary tree, which will consist of left node and then right node, and then it will consist of the root. So we need to find the leaves of this left nodes which are present. So suppose if we take this particular example where we have this particular tree. So for this particular tree, we need to find the leaves of nodes, and then we need to find the sum of the nodes which are leaves. Suppose if we take this one, and then if we take this, and then if we take this, so these three nodes are going to be leaves, but we need to calculate the sum of only the elements which are going to be left leaves. That means we are going to consider this one, and then we are going to consider this one. So if you want to find this particular sum, then we need to make sure that it is a left. That means suppose let's say I start from here. So whenever I start from here, whenever I am doing the traversal for the left node, then I am going to say that this is going to be my left. So I am going to pass it as true. So this is my left. And then whenever I am traversing here, I am going to pass it as false. So it will take it as false, and then whenever you are calculating this particular node, we'll check whether this is left or not. This is not left, so we'll not be considering this. And then one more thing is we need to make sure that this is leaf. So this is not a leaf, so we'll not be considering this now. So now here we are going to pass it as true. Why? Because this is a left node, and then this is a leaf. So we are going to consider this particular node, and then for this we are going to pass it as 5 false. Then it is going to be 7. So for this 7, it is we are not going to consider. Why? Because this is a leaf but not the left leaf. So we will not be adding into the sum. So let us go through the code once. So we'll be having the helper function which will help us to calculate the sum of the left leaves. So we'll be having the answer equal to 0 at the starting. And then whenever I'm starting the root, I'm going to say that this is going to be my false. So this particular root is not a left. That's why we are going to call it as false. And then we are going to have the root, the helper function which will take the root, and then his left is going to be false for the first time. And then we are going to have the answer. So let's say suppose we do not have any root, then we are going to return without doing any operation. Suppose let's say this particular root, this particular node is leaf. That means the left should be null and then right should be null. Suppose this is a root node, and then when we have left equal to null and then right equal to null, then we can say that this is a left. This is the node which is leaf node, and then we need to make sure that this is a left leaf node. So for that we are going to use is left. So this is going to give us the uh, boolean whether this particular node is left child or the right child. So this is the left. Then we are going to add into our answer. Suppose let's say this is not a leaf, or this is not a left. Then we are going to call the function for the left, and then we are going to call the function for right. So whenever we are calling the function for the left, then we are going to consider true. Why? Because this is going to be left child, and then for this we are going to call it as true or false. And then when we come to the time and space complexity, if we come to the time complexity, it is going to be big of n. Why? Because we will be traversing whole whole tree. And then when we come to the space complexity, it is going to be big of h or big of n itself. Suppose let's say the binary node will be like this. Suppose I have a node like this, and then I have node like this, and then again node like this. So we can have at the worst time complexity as big of n. Why? Because the nodes can be like this in this particular binary tree. So it is going to be big of h, which is going to be height, or big of n. Why? Because we are calling this particular function traversal for this time. So this is going to be our stack where we are going to have this particular space. But if we come to the without considering stack, it is going to be big of 1. Why? Because we are not considering any extra space other than this particular stack. Yeah, that's all for this video. Thanks for watching the video.